All right, so we wish to prove that if an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intercepted arc. So, in essence, we want to prove that you can see here that angle B is the inscribed angle, and it is equal to, the measure of angle B is equal to half the measure of arc AC, right? So this is split up into three cases. One where the inscribed angle, right, one of its sides is the diameter, right? Okay, so here we go. So in the case where it's the diameter, what we can do is we know that PB is congruent to PC, right? So we know that PB is congruent to PC, right? Because they are radii, right? And of course, this implies by the isosceles triangle theorem that the measure of angle B is equal to the measure of angle C. Now, what we can do is we can look at angle APC, right? So by the exterior angle theorem, we know the measure of angle APC is equal to the measure of angle B plus the measure of angle C, right? We know that this exterior angle, right, APC, is equal to angle B plus angle C. And, of course, that's the same thing as, this implies that the measure of angle APC is equal to 2 measure of angle B, because angle B and angle C are the same, right? So remember, since APC is a central angle, that means the measure of angle APC is equal to the measure of arc AC. So this implies the measure of arc AC is equal to 2 measure of angle B. And if we divide both sides by 2, that means that the measure of angle B is equal to half the measure of arc AC, which is what we wanted to show. We wanted to show that the measure of angle B is equal to half of its intercepted arc AC. So that's the case where we can see that one of the sides of the inscribed angle B is the diameter. Now let's do the case where they are on opposite sides of the diameter, right? So one of the sides of the intercepted arc, AB, is on one side of the diameter and the other is on the other side. So from case one, right? So let's go down a little bit. So by case one, I know the measure of angle ABD is equal to 1/2 the measure of arc AD, because we proved in case one that if one of the sides, right, if one of the sides of the intercepted, well, if one of the sides of the inscribed angle is the diameter, then we know that this angle is equal to half of its intercepted arc. Similarly, we know the measure of angle CBD, or I guess DBC, is equal to 1/2 the measure of arc DC. Now, naturally, this implies the measure of angle ABD plus the measure of angle DBC is equal to half the measure of arc AD plus half the measure of arc DC. And of course, ABD plus DBC is just ABC, right? Or angle B. So this implies the measure of angle B is equal to half, and then we can factor out the 1/2 measure of arc AD plus measure of arc DC. And then that's just the same thing as, which equals 1/2 the, I guess implies the measure of angle B is equal to 1/2. So arc AD plus arc DC is arc AC. measure of arc AC. So I've proven that if the sides of the inscribed angle are on opposite sides of the diameter, then we know the inscribed angle is still half of its intercepted arc. Now, the last case is, let's say, if both of the sides of the inscribed angle are on the same side of the diameter. So, naturally, we can just use case 1 again. So by case 1, I know the measure of angle DBC is equal to 1/2 the measure of arc DC. And I can see the measure of angle DBA is equal to 1/2 the measure of arc DA. Okay, so let me do a better job with that B. There we go. So, of course, I want to get angle B. So angle B is just going to be DBC minus DBA. So it's going to be the difference of these two, right? So that we know the measure of angle DBC minus the measure of angle DBA is equal to 1/2 the measure of arc DC minus 1/2 the measure of arc DA. And then, of course, DBC minus DBA is just ABC, or angle B. So this implies measure of angle B is equal to 1/2, and we can factor that out, measure of arc DC minus measure of arc DA. And then we can see that arc DC minus DA is arc AC. So this implies measure of angle B is equal to 1/2 the measure of arc AC. So you can see in all of the cases, right? In the first case where one of the sides is the diameter, in the second case where both sides are on opposite sides of the diameter, and the third case where both sides are on the same side of the diameter, in all three cases, we know the inscribed angle is equal to half of its intercepted arc.